Okay, so today the lesson is to use URLSession. We'll be using URLSession and encapsulating URLSession into a wrapper class. That wrapper class will be called NetworkHelper. NetworkHelper will be that class that we use in our projects going forward as far as accessing the network. Whether it be getting an image, whether it be creating Swift models, we'll be using that NetworkHelper class to do our networking code. Okay? But I want to make sure that I'm enforcing that at the interview, when you submit a project, please use URLSession, know what URLSession is. Know how to use URLSession by itself without having some NetworkHelper class in there, okay? Because at the end of the day, you need to know every line of code to be able to explain to that employer, to that interviewer, right? When they ask you what URLSession is, you're not gonna say like, oh, it's NetworkHelper. NetworkHelper does not exist in iOS, okay? This is a class that we write to help us facilitate our speed of programming. Right? That way, every time we write a new project, we're not writing the whole URLSession code all over again. Okay? So concepts we'll be talking about, we'll talk about URLSession. We'll talk about ResultType again. Right? And here we said that ResultType, did I not put it in there? Right here. ResultType, we said it's an enum with two cases. Either we have a success, right? The object we're looking for, we have it, an array, whatever it is, we have an array of jokes. Whatever that success case is, that object, we have it. So ResultType is an enum, two cases, either success or failure. Cool? So that's what ResultType is. URLSession, we said URLSession is a class used to make network requests. That network request, you can make a post request, you can make a get request, you can make a delete request, any of the HTTP methods we spoke about before, right? So some of the HTTP methods we spoke about get. We've been using get, right? We've been using get since we started using URLSession. Get gets me data from the internet. Next week, we'll start seeing post, right? Post, you have an object, you want to update your data, your account, whatever it is. You post, you send. Post is sending. Like similar as I say, I'm posting a mail, right? I'm sending something to somebody. So post is sending data to a web API. So get is retrieving data. And post is sending data. Okay? So we spoke about URLSession, we spoke about ResultType. The big topics as we build that NetworkHelper will be completion handler. We have our function signature, right? We've done it twice, but this time we really want to talk about what the pieces are. The completion handler is a closure, right? That closure, we need that closure in order to capture the results back from the network, right? So let's go to that diagram where we spoke about again in class. So we had a client, right? And we have a web API or a server, or we could say web API. So we make a request, the client sends a request. The client sends a request to the web server. I need to get some data from the jokes API, right? So the client here is our phone, for example. The client could be our phone or our postman. Postman is still a client, it's an API client. You make a GET request, I need some data, right? The server sends us back a response. That response we get back from the server is in that closure we capture. That's why we need a completion handler in our function to capture the results of the server's response, right? Responses the server sends, we have data, we have response, or we could have an error, right? So those are what we get back from URLSession. When we say URLSession.data task, right? URLSession has a completion handler or a closure in itself that has data, response, and error. And we said all those are optional, right? So data is optional, response is optional, error is optional. Because there's a possibility there's no error, there's a possibility there's no data, there's a possibility there's no response, right? Any questions? Cool. So let's keep going here. So we spoke about URLSession, we spoke about result. Completion handler here, we said it's used to capture the response data or error of an asynchronous network call. And yesterday we spoke about what asynchronous is, right? I make some call, I'm not waiting for it to come back. I'm not waiting, I'm going on with my business, right? I make a call, I'm going on with my business. When that call gets returned to me, I get the data back, whatever that data is, right? Whatever that response is. Yes, sir.
Aside from a closure, is there any other way to...
There's a delegate.
Okay.
URLSession also has, so URLSession, you could use a closure, and it also has a delegate. Those are the two ways. Those are the two ways to get data back from URLSession, right? 90%, 99% of the times you'll see closure being used throughout code bases and everything else we have, right? Because it ties perfectly with URLSession. You have your closure, you get back your data and your response. But know that URLSession has a delegate on it, okay? Cool. And keep in mind, anytime we're using URLSession by design is asynchronous. So like yesterday when we did data contents of, right? By design, it's synchronous. So we had to dispatch it on a global queue, right? So we had to explicitly dispatch contents of on a global queue. But URLSession by design is asynchronous. By design, it's on a global queue. By design, it's on a background thread already. We don't have to do anything else with that, right? So keeping that in mind, anytime the closure comes back in our ViewController, we're still on a background thread. That's why we have to explicitly go back to the main thread. Because you make your URLSession, you get back your data is ready, you want to present it to your UI, you'll get a purple error unless you say dispatch main, right? Any questions about asynchronous or completion handlers? And throughout network calls in iOS, it will be referred to as a completion handler, but keep in mind that's a closure, okay? So the two of them are synonymous with each other. So completion handler, closure, they're the same thing. That takes us into escaping closures, right? That takes us into escaping closures. Right? So we said it's an asynchronous call. We said we make a request. We don't know at what point we'll get that feedback from the network or that response from the network. We don't know. So we make our function, we write our function, we give it the task, and we have to mark it as escaping. Because the function returns, the closure has not completed its task, okay? So that is referred to as an escaping closure. That's referred to as an escaping closure, right? It escapes, it's not complete. I need to mark it explicitly at escaping. Even if you try, by the way, to not mark it at escaping, you'll get a compiler error. Because Xcode realizes that you're in a background thread, it realizes you're using URLSession, it realizes that you need to use an at escaping closure. It won't let you go ahead and continue your code. It will give you an error saying closure needs to be marked at escaping. Okay. That takes us into the final part of writing the network helper or writing some URL session. Anytime you're writing some robust code, if you say your code is robust, it's proof, right? You have to have error handling in there. Error handling is big, right? Because how can you know that the network is down? How can you know there's no data? How can you know the URL the user passed in is a bad URL? At every point of an error, you need to capture that error, right? Remember, developers, we need to think of the worst case scenario. What is the worst case that this is not working, right? So you need to bulletproof your code, or you need to be defensive. You need to be a defensive programmer. The same way we drive and we have a 5-hour defensive class, we need to have our code be defensive, right? We guard, right? Guard is one of the powerful defensive mechanisms we have. So we need to guard against errors, right? Do I have data? Do I have a response? Is the URL correct? Is my JSON good? Right? What are the possibilities we have here? There, put it. Right here. So we have bad URL. We have no network connection. Right? You're in the subway. No response back. No data. Bad status code. JSON decoding error. All those are errors, potential errors we could come across as we write our networking code. There's more errors too. If you're getting an image, maybe it's not the correct meme type, right? So keep that in mind as well. So meme type, error. For example, if you're looking for an image, JPEG, and instead of image, you get some like text, right? That would be bad, right? So if you really want to bulletproof your image code as well, you want to look for the meme type. And response, meme type is found in the response. In the response, in our 3 arguments, in our data, response, and error, in the response, you have a lot of data. There's metadata there. Everything about the data. There's headers, right? There's meme type. There's status code. The response has a lot of information, right? From the server, from the web API, about that particular piece of data that you're getting. Cool. So error is big. Error handling is big. And the way we capture error handling, anytime you want to do error handling in Swift, you use an enum, right? Enum, it's finite. It has cases. We could switch on those cases. We could use associated values. We could use associated values on enums. Those are great, right? Because I'm able to capture, is it a string that I want to send back to the user? Is it an error I want to send back to the user? In the case of a bad status code, I want to send back to the user, it's a 404 error. So I'm able to use an associated value on my error case and say, hey, it's a 404, or server is down, 500. And enum is very powerful for that. It is able to capture those values. So we'll use an enum for our error handling with the cases that we listed there. But keep in mind, there's always there might be an edge case where you want to add an X case. Very easy to add an X case, right? So if you want to do like a meme type, you could add in a case meme type error and show them what the meme type, they're getting back from the server. That would be very useful. Great. Any questions? So we highlighted everything we need in order to create our network helper wrapper, right? It's a URL session wrapper. It's going to take all the code that we've written twice and encapsulate all that code in a wrapper class. And that wrapper class, we'll call it network helper. And before we leave here, we need to talk about singletons, right? So a singleton, what's a singleton? A singleton is a design pattern. In all languages, there's a singleton pattern. We'll talk about design patterns. I'm introducing one of the design patterns now. Design patterns we've seen. Design patterns we've seen, right? We've seen object-oriented programming, OOP, right? We've seen MVC, Model View Controller. Keep in mind there's also a design pattern we might or might not get into here called MVVM. But in Apple ecosystem, MVC has been around for like 40 years, right? It's been proven. If anything goes wrong, it's the developer. It's always the developer's fault, right? We have our massive view controller. So MVC is also known for massive view controller because we tend to put all our code in the view controller. It's easy, right? It's easy to get to, easy to navigate, but before you know it, it's 2,000 lines of code, right? So the norm or the rule of thumb is anytime you get to 300 lines of code, you need to stop. So 3 lines of code in your view controller. If you get to 300 lines of code, you need to stop and think. What am I doing? How can I re-architecture my code, right? Am I putting too much model logic in the view controller? Can I take that out? Can I take that model model data out, right? So use 300 lines of code there as like a rule of thumb there. You should not exceed that. And really start thinking of architecture as you get close to that number. Like, what am I doing wrong? Do I have all my data logic in my view controller, right? Delegation is also a design pattern that we've seen, that we've used. It's throughout iOS. You have some view. How do I know that the user clicked on the search button on my search bar? How do I know? The view itself is done, right? The view doesn't tell me anything. But on the view, I could have a delegate, a protocol. I conform to my search bar delegate. Now I'm able to get information that the user clicked the search button, right? Data source is the same delegation pattern. Data source is also a delegate. It's called data source because it gives us data, right? Text field, how do I know the return button was clicked on the keyboard? There's a delegation for that. So delegation is throughout iOS, and it's a pattern that we use. We'll come across more patterns, but today we'll talk about Singleton. We'll use the Singleton pattern today. It has its pros and cons, right? There's a lot of cons, especially in the industry. Like, again, Singleton could be used really badly. You could have a manager, Singleton. That's like 2,000 lines of code. Because, again, it's easy. It's global. I could say user settings dot whatever. Get the information I want from any view controller, right? I don't have to pass information. There's no injecting anything. It's easy. Anytime it's easy, people use it, they abuse it, right? It's easy to pick up fast food, right? You just walk around the corner, get me some fast food, but it's harder to like cook at home, right? So anything that's easy comes really bad really quickly, so be careful there. Singletons could be bad because, again, it's a singleton, it could be used for a global state. I have 3 view controllers, different places of view controllers. I could say, hey, Mr. Singleton, give me the user data. I could change the user data from age 40 to age 51. A next view controller could say, hey, give me that user data. I could change 51 to 5. I have no idea who changed it, right? Because all of them have a handle on that singleton. So singletons could be very, very bad, right? So in the industry, it could be almost polarizing with singletons, right? Some people use it. It's part of Apple's ecosystem. It's throughout iOS, right? We've seen singletons. We've done bundle.main, right? So bundle.main, that's a singleton. Hey, bundle.main, I need to read from the resources folder. I'm not creating a new instance. On the type bundle, I have this method, method main. Just give me access to the resources. Right? That makes sense. I shouldn't have to create a bundle every time I want to read from the bundle. So I have a singleton for that. I could use it anywhere in my code. Other singletons we have UI application. That's shared. That makes sense. I want to update something with my application. I just say UI application that's shared. Change my background color or my tab bar color, whatever it is. I have access throughout the application with this singleton. We saw a singleton with URLSession. We use URLSession. That's shared. That's a singleton. Apple recommends that if you're using URLSession, you should have one instance of URLSession throughout your program. You shouldn't have multiple URLSessions. So they gave us this shared instance to use. If you want to use it, that's fine, because I know at any one point, I only have one session running. It restricts our application from not doing bad things, right? I don't want to have multiple different sessions running at the same time. That's going to be bad. So I have one session, and Apple recommends if you use URLSession without shared, you should have one implementation of it. So that's why we'll be using singletons in our network helper. Because we won't be using that shared, because that shared only gives you so much configurations. So we'll go ahead, we'll use URLSession, and we'll give it our own configuration, and we'll make our class itself a singleton. That way there's only one instance of network helper throughout our program, okay? So we'll take URLSession, we'll make our network helper a singleton. That way our network helper, we only have one instance throughout our program. Nobody cannot create a network helper. So making a singleton, a next big benefit of a singleton is nobody else, if I have a singleton, nobody else cannot create an instance of that class. So I can't say network helper. Once I make it a singleton, I cannot say network helper like that, right? This would be a compiler error. This would be a compiler error because part of the singleton is making the initializer private. So what are we going to do? We're going to make our initializer private. So making the initializer private forces or doesn't allow anybody to create an instance of network helper, right? Nobody can create an instance of network helper. The only way they could access network helper will be network helper that we'll call it shared, right? This is going to be our singleton. So anybody who's accessing network helper will only be using that one instance of our network helper. And why? The big why is URLSession should only have one instance. Everybody understands instance now, right? There should only be one of it throughout the class, throughout the program, throughout the application. Only one instance. Anytime you want only one instance of something, and you don't want anybody else to come in and say, hey, network helper, open parens, close parens, you make it a singleton. The benefits of a singleton, a true singleton, is all initializers are private. There's no way for somebody to create one of your classes, right? It's forbidden. So you put a lock on it. It's almost like making that class private, right? Well, it's almost private. The only way you could access it is through the shared instance. So Apple's convention, if you're making a singleton, you want to use Apple's convention for naming. You could call your singleton shared, like we'll do. You could call it main. You could also call it default, right? Because when we get to unit 4, we'll see what's known as user defaults. .default or .shared. I think they updated it too. All right, either .default or .shared, one of those. So we want to use the Apple conventions for naming our singleton classes. So today we'll use shared, because it makes sense, shared across the application. So that is singleton, right? Singleton is almost like a global variable or class that you have throughout the program. What makes it special is that private init there. Nobody else can create an instance of you. The only way they could access you is through this shared instance. We'll see that in code. So we'll make our network helper a singleton so that our URL session itself, there's only one instance of URL session throughout our program. Any questions? Any questions? So we spoke about some design patterns. Those are them there. The big one we're talking about today is Singleton. Did I hear something? Oh, that's Mr. Greg. Okay, cool. So let's go ahead and start coding. Any questions before we move on? Anybody wants to see extra notes? Those are all the notes we have. I'll slack out the notes when I'm done. So we have it. All right, let us go ahead and create a new project. So open up Xcode. And create a new project. Single view application. It's called NetworkHelper. Keep unit test selected, because if we do have time, we might create an asynchronous test for our NetworkHelper. So keep that checked. As a matter of fact, uncheck it. Uncheck it because I want us to be able to, if you've checked it already, just delete it and then recreate it. But I want us to be able to create, if we do make a test, I want us to create it from scratch because we haven't done that. Because I've seen some people that wanted to add tests after the fact with a project. So we'll see how to create a test target. Okay, that's why I said uncheck it. Okay, all right, so let's keep going. Next. And create. Before we forget or anything, let's actually create the test target now, even if we don't get to it, but let's create the test target now. So if you have a project, you don't have any test suites in there, you don't have any test targets, how does one create a target? Let's go ahead and do that. So in the navigation area, I'll click on my test navigator. Do we all see my test navigator? That diamond with the dash in there? So click on it. Go to the very bottom. Do we see a plus symbol? Do we see a plus symbol? Okay, click on the plus symbol. Do we all see new unit test target? Right? Not UI test target, but unit test target. Click on that. And it will attempt to use your project name, which is NetworkHelper, and it will append test to the end of it. So if you don't have a NetworkHelper test yet, it will take the name of your project and add test to the end of it. So that's pretty much what we want. That's fine. We'll go with that name. But if you want the next name, for example, you could totally change your name, but keep in mind, stay with the naming conventions, right? If you have a jokes API, you could call it jokes tests, right? If you have a weather API you're trying to test, you could call it weather test. Cool? So here we'll keep NetworkHelper test. And team is good, all that stuff is good, target is good. And the target you want to test is NetworkHelper. And now I'm going to click on finish. And let's see what we have. So go back to your project folder. And it's like we have the test from the beginning, right? So we have our NetworkHelper test module, our folder. And here we have our NetworkHelper test class, right? One other thing, it's missing some things, by the way. What is it missing? Import, right? It's missing @testable, because right now, if we attempt to use anything in our NetworkHelper module, it won't find it, because we haven't explicitly imported. So that's the one thing you missed when you say don't check. You missed the automatic @testable import NetworkHelper. So let's go ahead and add that, and then we'll keep going. So in order for it to see any classes in my NetworkHelper folder, I have to say @testable import NetworkHelper. Just build, make sure you have no errors. Great. For purposes of complexity, I'm not going to do test-driven development with the NetworkHelper. Okay? I'll go to the NetworkHelper, we'll create it, then if we have time, we'll come back and test it. Okay? All right, cool. So let us continue. First thing we'll add, let's create a new file. It's a Swift file. So new file, Swift file, and we'll call it NetworkHelper. NetworkHelper. Targets is NetworkHelper, not NetworkHelper test. But be careful there, right? Because we just came from the test folder. Make sure the target is NetworkHelper. Yes? Where? Make sure where is NetworkHelper. Okay? Group, make sure group is NetworkHelper, not the test. This is not a test class. And then click on create. Great. So first off, we ended our lecture notes by talking about Singleton, right? We need to make our network helpers a Singleton because URLSession is recommended that we only have one instance of it. Anytime you hear one instance, think of Singleton. Everybody? Okay, so here we need to make our network helper right, so we'll make network helper a singleton. This means there will only ever be one instance of this class throughout the application. At no point will someone be able to create a new instance. Example, network helper okay. So we'll start off by making it a class. And why a class? A class is reference. We have reference to one object. Okay? Why class? It's a reference type. We have reference to one object in memory. So here we have our class. It's called Network Helper. As is right now, anybody could create a network helper. Right? We'll go to the ViewController and we'll see exactly what I mean. I'll go to the ViewController and I'll be able to create an instance of network helper. Because right now, as is, it's not a singleton. So let's go over to the ViewController and see what we're talking about. So in my ViewController here, in ViewDidLoad, I could simply say network helper equal to network helper and build my application. And I won't have any errors. I'll have a warning because I'm not using it yet, but there's no errors, right? Anybody could create an instance. When I say an instance, this is an instance of network helper. We created a network helper. Everybody, back in unit 1, right? Instance, you create something. But we don't want that to be happening. We do not want anybody to create an instance of network helper. We want to stop that from happening. How are we going to stop that from happening? We'll make our initializer private. That way nobody has access to the private initializer, to that initializer there. Right? So let's go back to our network helper. Right? So here we'll make the default initializer private. required in order to be considered a singleton also forbids anyone from creating an instance of NetworkHelper. So how do we make it private? Well, we make it private by explicitly saying private init this. So at this point, if we build our application, we'll get an error. Automatically, all of a sudden, we have an error because our ViewController tries to create an instance of NetworkHelper, and the ViewController no longer has access to that initializer. So now go ahead and Command B, and we have an error, right? We have an error back in the ViewController. If we go back to the ViewController, we have an error here. What does the error say? The error says NetworkHelper initializer is inaccessible due to private protection level. I cannot access that anymore, right? So at this point, we have step 1 in our singleton is ready. It's ready to go. Good, great. So we could comment that out. Now the next question is, how do we access our NetworkHelper? If we don't have an initializer for it, how do we access it? So we'll go one step further. We'll create a singleton instance for it. We'll go back to our NetworkHelper. And we'll create a shared instance. How do we create a shared instance? We use a static keyword because we know a static keyword is being used on the type. So now we'll have the static keyword on the type. It will be a type property that people access. And that type property, we'll call it shared here. And as I said, Apple conventions, they use shared, they use default, they use main. Any of those names there would be suitable. Don't create like your own fancy name. It will be harder for developers to understand if this is a singleton or not. So we use naming conventions because it's easier for other readers to read your code and understand your motivations, right? So somebody sees NetworkHelper.shared, right away they're like, oh, that's a singleton, right? Without even looking at the code, they know it's a singleton by just reading what the name looks like. So here we have our NetworkHelper.shared, and this is the place that we could create an instance of it. This is the one place where we have the instance. So here we will create a shared instance of the NetworkHelper. This is the one and only place it's created. So the first time this class gets called, that instance gets created, it's in memory, I could use it throughout my program. Okay? Yes, sir?
So we made the
initializer.
primary initializer private.
Yeah.
If we created a convenience initializer, would we be able to
You'd-
make an instance outside of?
For it to be truly singleton, none of the initializer could be public.
Just as a question.
Yes, you can. Yes, you can. So Cameron's question was, if we created a convenience initializer and made it public, would it be accessible? Yes, it would. But right now, the only initializer that's even available is the default initializer, and that we made private. Okay? And keep in mind, for a singleton to be a true singleton, nobody else should be able to create an instance of it, whether it be a convenience initializer or any ordering initializer. At this point, it's no longer a singleton. Okay? Because somebody else could create an instance using a different initializer. Okay, cool. Very good questions. Great. So let's go back to our ViewController. And now in our ViewController, we could say NetworkHelper.shared. Right? It's not being used. There's nothing on there yet, but now that's the only way we could access it. Everybody? Right? So now we have this shared instance. We could use NetworkHelper.shared in any ViewController. Okay? Same as we have bundle.main, we could use anywhere. We could use NetworkHelper.shared anywhere in our code base where NetworkHelper exists. Okay? Great. So now we have our singleton. Let's keep going. Any questions? Any questions before we move on? All right. So we'll introduce URL session, and as I said before, Apple highly, 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 highly recommends that URL session in your application, there's only ever one instance of it. So here we'll create a private instance of our URL session. Right? So I have my URL session here. We call it session. And this is a class. I'm not giving it a default value, so now I need to give session a default value, right? Unit 1, right? A class, right? So here we don't have a default, we don't have a member-wise initializer. We need to go ahead and give session some value. So we'll give session some value in our private init. So here, session, we'll set session to URLSession dot configuration. And the configuration we'll use for now is a default configuration. But keep in mind, now we have more flexibility as opposed to URL session that shared before. That shared gave you what it gave you. It gave you some caching. But now our configuration, we could add more. We could add caching policies to it. We could say how long we want to save things. We'll not get into all that today. We'll build upon NetworkHelper as we keep going. But for now, we'll use the default configuration for URL session. So here we'll say default. So at this point, we have our session. It's ready. Our class got initialized, instantiated. We have the session. The session is ready to be used. So now we'll use the session as we've always been using. Any questions about what we just did here? We have a class. The session variable was not given a value. So we needed to give it a value in the initializer. We give it a value of URL session with a default configuration. And it's private. Nobody outside of this class has access to session. The only place we create our session is in the initializer, one time. There's one instance of it. Awesome. So let's go ahead and do URL session stuff. So we will, first of all, we'll create a function. We'll call the function perform data task. The objective of this function is to only get data. We've seen data for like the last 2.5 weeks. We know what data is. Data are bytes. Bytes you get back from JSON. Bytes you get back in the form of an image. Those are the bytes we've seen so far, right? We've seen bytes from JSON. We've seen bytes from an image, right? At the end of the day, we need data to do anything from the web. Anytime you download something, whether it be a zip file, any file you download, what you're downloading is data. And that data gets passed into some form, whether it be an image, whether it be our Swift models, right? Whether it be an MP3 file that you downloaded from some torrent. Don't download from torrents, guys. Right? So data is data. We love data because data gets us the object we want. So this particular perform data task will return a data object. But we're not going to say return data, right? Because we know what this is. So if I say return data here, will that work if I'm doing an asynchronous network call? Why? Okay, Jahid? The timing is not guaranteed when you get back the data, right? The function will return instantly. When I call perform data task, I get back data right away. What is data? Data will be always 0. It will always be 0. If you're doing an asynchronous call, which we are about to do, we're about to use URL session. Anytime URL session comes to mind, you know it's asynchronous. And you know asynchronous is not right away. You don't get that information back right away. It's not synchronous, right? You have to wait. In that waiting time there, we have a closure. And that's where we capture data, in the closure. Okay? If we go back to our notes here, where it says completion handler, we'll use a completion handler to capture the response data error from the asynchronous network call. right? So we have our function definition, which we have, our signature, which we have. It's called perform data task. In the parents, we'll have a completion handler. And that completion handler will have a result type, right? That result type will capture the data or the error, right? It will be two of the values. Either it's an error or either it's the data object in result type, right? Result type here. Result type is an enum again, two cases, success or failure. In our case, what do we have? Our result type will look something like this, where we have result and we have data or an app error, right? This is what we have in a completion handler, okay? Any questions about that? Because we can't just simply say return, we cannot just simply say return data, because return data works for a regular function, no asynchronous call. We get back data right away. But here we're making an asynchronous call, it's on a global queue, we don't know when we'll get back that data, we have to use a completion handler, a closure, okay? Any questions about it? Okay. All right, so here we have our perform data task. It will take in some URL string. So I'll say perform data task with URL string. It's some string. The string could be an image URL. The string could be an endpoint URL, right? Those are the two URLs we've been dealing with, right? Either I pass in some image URL that I want to download an image, or I pass in some Jokes API or some Yelp API endpoint. Those are URLs. That's what is expected. Yes, sir. Yes, I'm not done. You could remember a function could take closures, regular arguments. Yes, I'm not done. We're not done. But yes, the first one of the parameters will be the URL string. The next one will be the completion handler. So we'll put a comma, and then we'll add our completion handler. We'll call it completion. Again, we could call it completion. We could call it anything we want. It's a simple label. Okay. So here we have our completion. What's the big thing we need to do now? At escaping, right? And why at escaping? Exactly. After the function returns, we don't care when that happens, but we know our closure will get back the values when the values come back. And at some point, we'll get back a value. Whether the internet times out or we get back data, we'll get back some closure response. Very good. Everybody, Cassandra, right? Magiet, at escaping because the closure itself doesn't complete until the data comes back from the internet. So now we'll say at escaping. And at escaping here, let's go back again to the notes. And we're taking notes, right, as we're going on. So we said at escaping, we need to mark the closure completion handler with an explicit escaping since the method will return before, keyword here, the result of the closure is complete. Okay, those are the keywords. Cool. So we have our at escaping and we have our closure syntax here. Closure doesn't return anything. Keep in mind, I could do empty parents or I could also do void. They both mean the same thing. But where we have to add values is what the closure expects. Our closure expects some result type, right? So that's what we're going to be putting in there, some result type. And result type only has two values here. This is a generic. It uses the generic symbols. Generic is open angle, close angle, okay? Very similar to a set. When we create a set, we create a set of strings. We put in an open angle string, close angle, right? Set is generic, array is generic, but sets, that's the way you could initialize a set. You have to explicitly say angle brackets, okay? So when you see angle brackets, think of generics. Generics, we'll see generics next Wednesday. Generics allow you to use any data type, okay? Generics, same as arrays, you could put in any data type inside of an array, correct? Can I put in an int inside of an array? Luba? Can I have an array of ints? Can I have an array of strings? Can I have an array of bools? Can I have a mixed array? Yes. Okay? You can have an array of anything, really. anything. Okay? You could have a mixed array. That would be called a heterogeneous array, where it's an array of any. And the reason why we could do that, because array type is generic. Generic implies it works on any data type. Okay? So here, our any data type, the first data type is the success part of it, what you're expecting back. In our case, we're expecting back a data. And the second data type here, it needs to conform to error. That's it. So when we say any, when we say generic expects any data type, there's restrictions. My generic could be constricted or restricted to a specific protocol. Right? We'll talk about more later here. But data could be anything. I could have a string as my success. I could have an array of jokes. I could have anything for the first part of my result. But the second part of the result, it needs to conform to error. As long as that type conforms to error, the compiler doesn't care. Okay? All right. So the first part we said it's data. So data is our success. And second is error. For now, we'll put in error. We'll update what error is here. Error will be our app error. We'll create a type. Our type will be called app error. Response will be from the status code. We're not returning response. But response will have the status code. Cool? Okay. So we said error, the second data type for result, only needs to conform to error, the error type. Okay? The first part, the compiler doesn't care what data type it is. I could have any type. I could have data. I could have an array of jokes. Like if we had a joke model, I could have an array of jokes. I could have an array of weather. I could have a dictionary of weather string, right? You see where I'm going with that? The first one could be anything. That's what the data you're trying to get back, that success data could be any type. Yes, Amini? Yeah. As long as the compiler sees where weather is or whatever that type is, it's fine. Like for example, I could have a string. I could have string int, a dictionary here. See what I'm saying? Anything. That generic doesn't have any limitations. The generic type that has the limitations is the error, the second one. It has to conform to error. Because remember, success or failure. If the thing fails, it's an error, right? So it needs to conform to error. Does that make sense? Right? But the success, I don't care what you say success is. Success could be whatever you want success to be. Maybe it's an int, that's all you want, the status code. Only two. Yes, result type success or failure. You could return a dictionary, an array of arrays. Yeah, exactly, a tuple. Yeah. All right, cool. So, but what we're interested in here is data. Because at the end of the day, our network helper needs to be generic in the sense that we only want data back. We don't want like an image or we don't want like an array of jokes because now it's coupled to jokes, right? We want to decouple. When I say decouple, I want to take the dependency away. I don't want my network helper to depend on the jokes API. Like we did jokes API, right? The jokes API client with URLSession. That class was dependent upon jokes. Or what it returned was a jokes array. Remember, our result type was a jokes array. So here we don't want to do that. We want to say, any API I use, I just want to get data back. Right? As long as I have data, my client itself could do whatever it wants with that data. Okay? I just want to get data back from the internet. What I do with the data, it's up to me. So that network helper, its only job is to get us back what? Data. That's it. Not an array of jokes or an array of weather. That we'll create with a different class. Okay? That's known as decoupling. You break them away from each other. So now, network helper is not dependent upon any API. Okay? The better you could write code like that, the more reusable it is. For example, our bundle.main is by itself in an extension, right? Now I could use it anywhere. I could say bundle.main, get me back data. That's it. But if I tie bundle.main in an API somewhere, I have to write that code everywhere I need it. Go ahead. The whole JSON file, exactly. Or image, right? Image is not JSON, image is just a blob of data. Good? Very good. All right, so here we have our app error. Let's stop for a second and create a new file so that we take care of app error really quickly. So let's create a new file here. Our new file will do the error handling. The error handling we spoke about earlier, that's what the new file will do. That new file will have an enum with the cases of errors we expect. And those cases we spoke about here, those are the cases we spoke about. We have a bad URL, we have no network connection, we have no response, no data, bad response, status code, decoding error. So those are the errors we'll handle in the enum. So let's go back to the enum. So it's a file, Swift file. Next. And we'll call it, we could call it network error, but for now we'll call it app error. And again, make sure that it's not in the test suite. Make sure it's just NetworkHelper, 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 and then click on create. Great. So let's go ahead and create our, and here this is error handling. Error handling against network request.
So if you don't do this, your app will crash. And if you do this, it will just show the message.
Yes, like when it crashes, you want to get that, well, it's not going to crash. It shouldn't crash because we just had showing you errors. Instead of crashing it with a fatal error, we'll show the error.
Will it freeze?
No, it won't freeze. Like for example, if there's no network, it's not going to crash the app. It will let the user know there's no connection.
And if you don't do it, it just won't.
If you don't do it, it's not going to show the user what the error is. Like if I cannot post my Instagram photo, I want to know that I have no connection. What Instagram does, they show you a red label, right? Yeah, you want to let the user know what went wrong. So you're not going to do a print statement. Like I'm not going to say print statement. The user never sees that. So anytime you send in, either you're doing an app for the App Store or you're sending an app to an interviewer, print statements are not the thing to do. You want to show what went wrong, right? Is there no connection? Is it a bad URL the person put in? Whatever it is. Show. Always keep that user aware what went wrong, right? The last thing you want to do, you post something, you got no feedback, you thought you did, like a Slack message, for example. If you try to Slack and you have no connection, the message doesn't go out, period. It tells you there's no connection. Cannot send message, try again later. But can you imagine a scenario where you send your message, you got no feedback, you thought it went away, and then you come back, the person's like, why are you late? You never let me know you're late. I sent you a message, you know. That's not good user experience, right? So always give the user feedback there. Very good. So we said error handling against network request. Some errors could be network connection lost, for example. Cool. So we'll create our enum. And we said we're using an enum. Why are we using an enum? An enum is the easiest way to capture error states throughout your program. Case, no connection. Case, no response. Case, bad URL. Okay? So here we'll say enum and we'll call it app error. In order for this to be compatible or work with ResultType, what do I need to do? Conform to error, right? According to Luba here, I need to conform to error. Oscar? Right? I cannot now just say ResultType data, comma, app error. I need to conform to error. Actually, let's go ahead and try it now without doing that. So let's go to NetworkHelper and remove error here in my ResultType and just put in app error and Command B. And we get an error. Right? Type app error does not conform to protocol error. Right? Very similar to like Codable. If you're not conforming to Decodable or whatever it is, you get an error. Hey, if you want to be able to get stuff from JSON, you need to conform to Codable. Here, if we want our result type error, app error, to be an error, it has to conform to error. Okay? So let's go ahead and update our app error. and conform to the error protocol. At this time, if we build, no, but there's an error. Return, oh, okay, that's fine. Cool. All right, so at this point, we are satisfied that our app error works because there's no error anymore in our network helper. We could go ahead and do the cases that we know are coming through. So we could start off with the bad URL. So case bad URL. And here, what did we use as an associated value? A string, right? And string here is an associated value. What's an associated value? What is an associated value? Benvenuto, what's an associated value? Right, everybody heard Benvenuto? Say it again. Right, so Benvenuto says, we have our case bad URL. If we want to capture any relevant data around that case, we use an associated value. So here we want to capture what the URL the person entered was. If we do not use an associated value, there's no way to know what that URL was. So we use an associated value to store that value. We could have multiple associated values. I could say string, comma, bool, comma, int, comma, string, and so forth. Right? I could say string, comma, string, comma, string. That's fine. Everybody? Cool? So here we have bad URL, associated value on our enum. Great, great, great. We'll go ahead, we'll say case no response. We'll say case no network or network client error. Network client error actually throws an error, or there's an error there. So we'll capture that error. We have no data in case data is nil. We have decoding error in case our JSON is bad. Oh, not JSON is bad, but our code, our model is bad. And we have bad status code, 404, for example, or 500. Anything that's not 200 we'll consider as a bad status code. And for bad status code, what should I use as the associated value? An int, right? According to May here. So I'll go ahead and I'll use an int to pass in what the bad status code was. For example, if it was a 404, 500, and so forth. Yeah? Yes, so the decoding error will be that one, because it will throw a catch, like our JSON decoder will throw an error, and in the catch block, we would have that decoding error there. Yes. Yes, exactly. As we write our networking code, in each block of that code, as we're going through it, the error part, the response part, the data part, the status code part, there's a potential for something to go wrong. Yes, exactly, exactly, exactly. And for now, I'll just put in bad meme type here. And remember, meme type is a multimedia type. For example, image, MP3, text, HTML, all those are meme types. And for the meme type, we'll capture a string. A case where there'll be no data, the actual response doesn't return any data, like it's empty, like the server itself. In that case, the response code might give you more information, right? Like maybe the server is down. So meme types, an example is JPEG here. Ooh, don't break it. All right, so our error states have been handled for the most part. Always keep in mind, we could come back and tweak this as we need. This is fine, it's an enum. Let's go back and continue our code. So we're in perform data task. Our function signature is pretty much done. It's done. It's done. We have our URL coming in. We have our completion handler capturing the result type, whether it be data, success. The only time we have data here is if it's success. And then anything else is an app error. And here, let's remove that return data because we're not returning. We know why. Everybody knows why we cannot just return data, correct? Any questions? Majed? Good? Amini? Okay, that's good. That's what I want. So if we say return data, it will always return 0. Data will always be nil or empty because the function returns right away. In my ViewController, wherever I'm using this perform data task, data, if I say function perform data task, and I'm expecting data back, it will return right away. The closure has not completed yet. So where I expect my data, I won't have data. It's going to be empty because it's an asynchronous call. So when I say perform data task, get me back data, it will always be 0. Always. Why? Because the closure itself is asynchronous. It doesn't return until the data comes back. Right? No matter how fast your computer is, you'll never get data as being that expected data you want. Right? If it wasn't a escaping closure, we could have said return data, as we always do in a function. Yeah, the function just returns right away. So you call a function add to numbers, you get back the return right away. But if it's asynchronous, there's a delay there.
But it's still returning data.
Eventually, in the completion handler, we'll get back our data. Yeah, but not with arrow return data.
Yeah.
Cool? All right, cool. Oscar? All right. You'll try it. You'll come to those cases where you'll try it at some point, whether it be accidentally or not, and you'll be like, why is data 0? Then we'll take a look at the code. We'll be like, oh, this is on a background thread. You always get 0 because the function returns right away. The closure is not. It's asynchronous. No matter how many calls you have, an asynchronous call will always return after the function returns. Cool. All right. Good. So let's keep going here. So we need to use URLSession now. We have our session. We'll create a data task for it. So URLSession returns a data task. When I say URLSession.dataTask, it returns a task. On that task, I'll say resume for the actual request to happen. So first off, let's say session here dot data task. And we say data task with URL. Next week, we'll start seeing URL request, but not today. But today, we'll just use URL. So data task with URL completion handler. Press enter for the URL. Oh, we need the URL. We don't have the URL yet, but we could fill in the rest of the data points. Okay, we need a URL. That's the only error we have so far. We'll get a URL by creating a URL using the URL string that the user passed in. So let's go ahead and create a URL. So here we have URL equal to URL initializer. It expects a string. So we pass in our URL string here. And this is a guard. We return. This is the first place we could have an error. Yes, Amini, go ahead. Go ahead, what's the question? Got it, sure? What was the question? Okay. All right, so we have on line 34, we are creating a URL using the URL string. This is line 34. I'll just put a comment here. Creating a URL from the given URL string, from the given string. Okay, we're not gonna just leave the code like this. This would be bad. If we say return without anything, without capturing anything, the user wouldn't know what went wrong, right? If we simply say return, it's a silent return. We don't get any information back. Like whoever is using NetworkHelper doesn't know what went wrong. And that's the last thing you want to happen, trying to debug something and don't get feedback. The more feedback you get as you're debugging your code, the better. So here, we could have a bad URL if we return in here. If we return in here, something went wrong. So let's use our app error. So handle the case, handle that error case. That's an error. So handle bad URL error case. And the way we handle it, with our completion handler, it failed. If we got here, it failed. It failed. What is the error that I'm going to pass in? We created our app errors. Which error am I passing now? Bad URL, right? So I'll simply type in .bad URL, and I'll pass in the URL string that the user gave me. Right? So you pass in some URL, it has spaces in there. I'll get back an error saying, hey, your URL, take a look at it, because there might be errors there. And you'll be like, oh, there's a space in that URL. Or it's like HTTPS, not HTTPS, or whatever it is. So at this point, the user gets feedback that the user is the user of the network helper here. Awesome. So next step, let's keep going here. So in our data task, we've done our request. And always keep in mind the reason why we do this data task here as a constant, so that we don't forget to do resume. Okay? Always keep in mind, I'll do it again here. This is not going to give you any compiler errors. This is fine the way it is. But the request will never come back, because it's in what known as a suspended state. As per the API documentation, URLSession by default is in a suspended state. Suspended means that it's not actually returning the response that you expect. It's not going to return the response. To return the response, you have to explicitly say resume. Resume network request, right? So there's two states here. Two states on data task. We have resume and suspended by default. Suspended simply won't perform network request. This ultimately leads to debugging errors, time lost. If you don't explicitly resume request. Okay? So you'll be like, I'm doing everything correctly, I'm not getting back data, we'll take a look at your code, we'll see that all you forgot was .resume. Right? And again, the compiler doesn't give you an error, right? The simple fact is, by default, the data task on URLSession is in a suspended state unless you explicitly say, resume the task. Like, please carry on with the task for me. Okay? That would be nice if it was by default resume, but it's not. Okay? So to avoid that from happening, get in the habit of saying let data task equal to, because at this point you'll get a warning if you do not use data task. And you will remember to use data task here because you have a warning, and we do not submit codes with warnings, right? We do not submit codes with warnings. So now we say resume, and the task is resumed, and we get back our response and everything as we need. Great. Any questions? Yeah. So far we only did bad URL, but we have more to do in line 47. Yes, exactly. Okay, so let's continue on here. App error. Make sure to build, by the way, because Xcode sometimes delays there. Cool? Yeah, go ahead. Oh, we introduced today, we're saying that we're not using that shared. We're going to use configuration default. That's why we created the session variable, and we have our session being configured in the initializer. Because later we might have different caching policies. You cannot be flexible with that shared. That shared is a singleton. It is what it is. It doesn't give you access to anything else. Cool? Any other questions? How are we doing? Good? Want to take a break here and come back? Okay, so let's stop here and we'll come back.